Stay hungry, stay foolish.
Marshalling unique insights from archaeogenetics, an emerging new discipline that allows us to read our ancestors' DNA like journals, chronicling personal stories of migration. Our guest charts 2 millennia of adaptation, movement and survival, culminating in the triumph of Homo Sapiens as we swept through Europe and beyond in successive waves of migration, developing everything from language, the patriarchy, disease, art, and a love of pets as we did so. As well as being a radical new way of telling our shared story, today's book is a reminder that the global problems that keep us awake at night, climate catastrophe, the sudden emergence of deadly pandemics, refugee crises, ethnic conflict, overpopulation, are all things we faced in the past and overcome. Our guest is one of the most established international experts in the field of archaeogenetics. He is director of the Max Planck Institute for Evolutionary Anthropology in Germany, and he is author of A Short History of Humanity, How Migration Made Us Who We Are. Johannes Krause, welcome to the show.
Thanks, Aidan. Thanks for having me.
It's fantastic to have you on the show, Johannes, and I have a copy of the book up for grabs for our audience. Just sign up to the innovationshow.io newsletter and you will be in with a chance to win a copy of this amazing book that is just so dense with information, and I'm dying to get into today's show. So let's start with some context, Johannes, and get everyone up to a common level of understanding, as common as we can, because let's perhaps start with a whistle-stop tour of the field of archaeogenetics and your career, and with that 70,000-year-old finger bone that altered the course of scientific understanding.
Yeah, so this was a story that started more than 10 years ago when I was doing my PhD at the Max Planck Institute for Evolutionary Anthropology, where I'm now back and actually heading a department, which I would have never imagined as a little undergraduate student or graduate student. But yeah, that's how kind of fate happened to me. But what happened back in the day was that I was working on ancient human bones, which sounds a bit weird maybe to some people, but basically what we do is we extract DNA from ancient bones and try to reconstruct the genetic makeup of those people and see how those people relate to each other, how they're related to each other, or how they're related to individuals from today or from the past. And back in the day, I received a little package that had a bone inside. It was actually more or less an envelope that came from Russia, from a collaboration partner from Siberia. And it contained a little piece of bone that at the time the archaeologists thought would be from an early modern human, so one of our direct ancestors that maybe lived some 40,000 years ago in a cave in Siberia called the Denisova Cave. And at the time, my project was to look how early modern humans, so our direct ancestors, are related to people that live today. We had just developed new methods to actually look into how can we distinguish ancient modern humans from modern people, because our DNA is very similar, obviously, because they are our direct ancestors. And at the time, it was not so easy to distinguish their DNA from, say, contamination, that if archaeologists, they touch a bone or there might be DNA flying around in the lab. So we just developed new methods to actually compare those and finding if it's really authentic ancient DNA or not. And when I analyzed the DNA of that bone, I figured out that that is actually not DNA from a modern human. And it is also not the DNA of a Neanderthal, which was the other type of human that we were studying at the time, but it was actually DNA of a yet not known human form. It was different from humans, from modern humans. It was different from Neanderthals, and it had diverged. So it had split from our ancestors based on the DNA sequence that I could obtain from that bone about 1 million years ago. And it didn't really fit in any box. So it didn't really fit like what we would call Homo erectus, which is a very early form of hominin that left Africa maybe 2 million years ago, but that would have separated from our ancestors 2 million years ago, not 1 million years ago. And it was also not a Neanderthal, that was clear. So we didn't really know what it is. And we were really baffled and excited and amazed by this kind of new hominin that we had found just based on DNA from a tiny little piece of bone that we now call the Denisovan. So we basically gave it a name. Very similar to the Neanderthal that was found in a valley in Germany called the Neanderthal, so Neander Valley, that was then called Neanderthal. And we kind of did the same here for the Denisova human. We called it the Denisovan based on the cave where it was found, the Denisova cave. And now we've found out much more over the last 10 years. There was then some of my kind of additional research, but I also then left the department and the lab of Svante Pebo where we did this research, and he did much more work over the last 10 years. I have actually diverted a bit, and I have, as we will talk about more, focused my research into more recent periods, into modern humans, into our direct ancestors, into historical and prehistorical time periods, and into diseases. But they have continued to work on the Denisovan, and we have found so much out about what Denisovans are, how they're related to us, how they genetically contributed to certain people in the world today. So there are certain populations, like people that live in the highlands of Papua New Guinea or Aborigines from Australia, that carry about 5% of DNA from those Denisovans. And they even left their DNA in other East Asian populations. So, for example, the people that live in the high plateau of Tibet today, they carry a gene that allows them to live on high altitude that they inherited from Denisovans. So, which tells us that they had at some point exchanged genes. So there was some gene flow between those, what we call archaic humans, so some early hominins like the Denisovans and the Neanderthals, and modern humans that spread over the world some 40,000 or 50,000 years ago. And they had sex with each other, they had babies with each other, and that basically accumulates in this type of ancestry and this type of DNA from those hominins that we see in different parts of the world.
And one of the things that happened, Johannes, for you was the speed of change. So you tell us that mapping out someone's DNA currently costs less than a full blood panel. So it is hardly surprising that today or in the future, parents will start routinely requesting the decoded genome of their newborns. I'd love if you'd share this, because this is something that comes up on the show, but it's also something that you took advantage of in your research.
Yeah, we've been extremely lucky to be at the right time at the right place. So I started my PhD in the Department of Svante Pebo in 2005, who was just starting the Neanderthal Genome Project. So trying to decipher the entire genome of the Neanderthal, which was a big honor for myself because, in fact, I was born in the same village like the person who discovered the Neanderthal, which is an amazing coincidence because I discovered the Denisovan, so that the two discoverers of the kind of hominins that lived in Eurasia over the last 500,000 years were born in the same village somewhere in Germany is just incredible.
I was so happy when I saw that, because, you know, when a seed gets planted as a child some way, and obviously that happened for you. So I was delighted to see that happen.
Yes, exactly. I think it was that seed, because that person was the most famous person from my village, and there was a big monument about him, and the school was called after him, and the main street was called after him. So therefore was some sort of predestiny, I think, that I somehow ended up going in a similar direction. It was like you described, it was like a seed that was planted. I always was interested in anthropology, and when I had the chance to combine anthropology with genetics, which I'm a biochemist by training, that I could combine both together, I was just amazed. And I was really burning for that topic. And I think that is also very important as a successful scientist, that you burn, that you really are super excited, and that you basically bring that into your research. It's kind of drive. And I think I was really kind of, I think that was already from my childhood given in a way. And then I was lucky to be at this institute at that time, because there was a time when a new technology was pioneered and introduced into the field of genetics. It was what we now call next generation sequencing. Now we're already at next generation sequencing or so, but now we sometimes also call it high throughput sequencing. So it meant that new machines became available that were 100 to now 100 million fold faster in sequencing and deciphering DNA than the machines that we had before. So at the time when I started my PhD, the best machine we had in the lab produced 100 DNA sequences per day, which was the best machine. It was like the kind of Ferrari of sequencing machines. It was like super expensive and super good. But then the next machine could already produce 100,000 DNA sequences a day, so 1,000 times more. And the best machine we currently have in the lab produces 100 million fold more DNA per day. Which is Lumina, which is kind of the current technology. So it really, the throughput has increased by many orders of magnitude over the last 15 years. And that allowed us to decipher DNA much faster than what was possible before. So at the time, 15 years ago, it took us about several years to actually decipher the whole genome, to kind of basically puzzle it back together. And it would have cost, like the first human genome, billions of dollars. I think it was $2-3 billion for the first human genome project. And it took people 10 years to actually bring it all together. Now you can do that in one day for hundreds of genomes in parallel, and it costs you several hundred euros only. So from billions, we came down to 100 euros. But there's also in other places in the world, many companies now that decipher genomes for a very affordable price. So you can get genome-wide information for less than $100 now. You can send your saliva to such a company and they actually do a genome analysis. And now we have millions and millions of people worldwide that have the genomes deciphered and analyzed in large medical studies, as well as just private companies. Just people are just interested. They're interested in the ancestry. They want to know, where do my relatives come from? Especially for North America, it's really interesting because they have ancestors from all over the world quite often. And they see whatever. I have 20% Irish and 10% African American and 30% East Asian ancestry. And they can really track that now with genetic information for a very affordable price. And this similar technologies we could then also use to decipher the DNA of people that lived in the past, what we call ancient DNA, that allows us now to really then establish the relationships of modern people to past people and to past people among each other. So similar to what those companies do that look at ancestry, we look at the ancestry in the past and are basically then able to reconstruct the scaffold that our modern genetic variation is built on top of. So how did people end up where they are today? How did they migrate? How different populations are related to each other, not just today, but also in the past. And this has become this field that we now call archaeogenetics, a combination of genetic information, but from archaeological material that then tells us about relationships from kind of past populations.
I thought it interesting, and I just wanted to highlight as well, because you mentioned the damage wrought by years of pseudo-scientific publications, because it's still felt today. And for you as an archaeogeneticist, it's hair-raising to see how many misunderstandings about genetic heredity remain in circulation and how brazenly they're touted and sold to the public who don't know any better. I thought that was important to say because you have debunked a lot of the myths. You've shown, for example, that many of us spring from Charlemagne in France, for example, and that we need to be careful when we're investing in such things.
So yeah, there is a lot of people that feel that they have some genetic link to ancient populations, but in some sort of pure form, that they descend from some sort of Celtic population, from some valley, from some region, from some part of Europe, and they feel their DNA is Celtic, their DNA is whatever, ancient Iberian, or they really feel connected to this one place over thousands of years, which, partially might be right, but to a large extent is also wrong, which most people will see when they do an ancestry test. They will get part of their DNA is from Central Europe, part of their DNA is from Southern Europe, part of their DNA is from Scandinavia. If they are European, and if they're North American, they will see they have a whole potpourri of genetic heritage. And that is true for everybody. And in fact, I haven't seen anybody who is kind of pure one thing from the past. And that is just because of the sheer amount of ancestors that we have, which a lot of people are not aware of. So we can think about our parents, grandparents, and grandparents, but then it doubles every generation. So we have 4 grandparents, 8 great-grandparents, 16 great-grandparents. But what a lot of people don't do is play that game even further back in time. If you do that over 10 generations, which is roughly 300 years, so sometimes 17th, 18th century, we have 1,000 ancestors. If you play that game over 800, 900 years, you have 1,000 times 1,000 times 1,000, which is 1 billion ancestors, right? So over basically the last 900 years, back to the medieval time, each of us has, mathematically at least, 1 billion ancestors. And it has been actually shown that every European is related to every European over the last 1,000 years. So we're all related to each other. So therefore, it feels kind of weird to say, I have this kind of direct link to those people 2,000 years ago, when everybody's related to everybody already. So it might be that they have a bit more ancestry from one population compared to another population, but nobody is a direct lineage because we're not bacteria. We're not doing part of the genetics where we just kind of like divide ourselves. It is really, that we have a lot of ancestors. And I think that's a much more important piece of information, that we're all related. And over several thousand years, every person on the planet is related to every person. In fact, 50,000 years ago, we still were Africans, people outside Africa, and left Africa 50,000 years ago. And in fact, people from from Eastern Africa are closer related to people outside Africa than to people in West Africa. So in a way, we are even an African tribe to people outside Africa. So those types of information, I think, are important, and a lot of people don't have that concept of what ancestry actually means, and that we have so many ancestors in the past. What is also important, and that's especially for noble families that often have like a pedigree that goes back to 1250, and this knight was my ancestor for whatever kind of a noble family from kind of some castle somewhere in whatever England or so, let's say. And they're really proud of that. But what they don't think about is that actually they have nothing in common genetically with those people already over 10 generations. So if you have an ancestor that lived 300 years ago, 1720, that's 10 generations away. The chance that you do not have any piece of DNA from that person is higher than that you do have a piece of DNA from that person. So even though you know this is my ancestor who lived in 1720, there is a higher chance you have nothing genetically in common with that person than that you do have something from him, because you have 1,000 ancestors over that time period, and the chance is higher that he doesn't give you anything than he has inherited something to you, because it also means you have twice the number of ancestors per generation. It also means you get half the material of genetic makeup from that people. So even the pedigree doesn't mean much at all. So if people have a pedigree that goes back to 1250, I'm probably as closely related to those kings or knights, and you as well, and most kind of people that live in that region are as closely related to that person as that person himself, because nobody kept completely clean, right? Of course, that's what those noble families kind of want to say, that they were always just kind of, having children within their own lineage, but hopefully not as much. Otherwise, they become some Targaryen family from Game of Thrones or something like that, and siblings get married to each other or something, which causes, of course, all kind of problems, which some noble families had. I mean, we also have to see that also happened, that they had a very high kind of genetic load, how we call that. So they had a lot of genetic diseases because they did practice endogamy a bit too much, I think. But if people don't do that, and if they marry out, then usually we have an incredible amount of ancestors.
I love this. And I'm going to come back to that because it's a really important factor for the racial segregation that we have today, because you even talk about skin color and how skin color is an adaptation to the environment or where we live in the world. I'll come back to that, Johannes, because I want to try and keep on the track so our audience can build understanding like I did, because I found the book was fascinating for how you wrote it. So you build and build and build and bring us on this journey, and bravo to you, because also this book, it was originally written in your native language, German, and translated magnificently, by the way, into English. You did a fantastic job with that. But you mentioned there about mutations, because I think this is really important, because our concept of the word mutation is a negative one, and it holds unpleasant connotations for many people. But mutations are the engine of evolution. They're the reason human beings and chimpanzees stand on different sides of the fence at the zoo. Mutations are the milestones of human history. I'd love if you'd share this.
Absolutely. So mutations are, of course, driving evolution. If mutations wouldn't happen, we would still be some sort of slime in an early ocean like we were 3 billion years ago. And of course, due to the mutations, things changed, right? We became more complex. From a unicellular organism, we became a multicellular organism. We became more complex organisms. We became, at some point, vertebrates, and at some point mammals, and at some point primates, and at some point apes, and at some point humans, right? So those were all steps that we had to go through over like a million and even billions of years of process that it's called evolution. And mutations are just the driving, basically, factor of that, which just means that there's changes which are random. They're introduced into the DNA, into the makeup, into the blueprint, and then they change the building blocks slightly, right? Which can often be bad and deleterious, and that's the mutations we think of. Doesn't mean that we get laser beams shooting out of our eyes, or become superpowers and become kind of like attract iron like Magneto or something like that. But it's more that in fact what happens is that often things break. If a mutation happens, which is bad, and there's a lot of genetic diseases that are caused by such mutations. But sometimes things also improve. For example, there are people on the planet that can see 4 colors instead of 3 colors. Most of us, like you and me, I'm 100% certain, we are just trichromats, how we would call that. We can only see 3 colors, maybe only 2, because some men can only see 2 colors. But there's some women that can see 4 colors because on the X chromosome, and they have a mutation that kind of renders the spectrum a bit, and then they can actually see 4 different colors, which is really awesome, right? They don't even know, they're not even aware of that, but their world is much more colorful than kind of our normal world. And there are other things that happen, like people can smell different things and taste different things. And some people might even be more athletic than others because of some genetic mutations that they have inherited. So at some point in our evolution, we, for example, inherited mutations that were rising, that gave us an upright posture, walking on 2 legs, and a bigger brain that was slowly becoming bigger and bigger over the last 2 million, 3 million years in our evolution. And those little steps basically made us who we are today. There were many things that went wrong in those mutations that kind of made just break things in our genome and our building blocks, which is bad, but sometimes they're good things. And then there's this process which is called selection, which Darwin described so wonderful in The Origin of Species more than 150 years ago. And in that book, he basically laid down how evolution works, that mutations happen, they bring up new phenotypes, and then selection either weeds them out if they are bad or selects them positively. And then those might procreate more, they might have more children, they become then fixed in the population, and they kind of change slowly the genetic makeup. But it's really like drizzling rain that kind of drizzles in our genome. And those mutations that are really favorable, they get selected for, and the ones that are bad get selected out. What we use in our work in genetics are, however, often mutations that don't do anything, which is also interesting. So it's not that if the DNA changes, it has to either be good or bad. Often it just does nothing. There is millions of positions in our genome that vary between people. Like if I look at your genome and my genome, I will probably find about 4 million differences. But most of those actually have no whatsoever impact on our phenotype. They're just neutral, a neutral variation, how we call that, because large part of our genome is actually not coding for anything. We always think about our genome as this blueprint and as the building blocks, but only 2% of our genome are building blocks, what we call genes. The rest, 98%, are what we call non-coding. Some of that are regulatory elements. They switch on and switch off the transcription, so whether genes are active or not active. But at least 50%, maybe even more of the genome is what we call junk DNA. They don't do anything. They're just placeholders. They're just there. And the mutations that happen in those placeholders, they're actually very useful for us because they're neutral. So they're not under selection. So then they behave like what we call a molecular clock. So basically, because they rain down on the DNA over time, the more mutations you see between 2 different types of DNA sequences, the more time has passed. And that you can actually use to infer when, for example, populations separated from each other. So we can really use mutations also to tell genetic history, to tell when did populations have their last common ancestor, when did they diverge, how closely are they related, how distinctly are they. And that is something that we can actually also use as well. So mutations, on the one hand, can be bad, they can be good, but they can also do nothing. But then they're really useful for us geneticists who use them to tell what we call genetic history, to look at how populations have been related in the past.
I loved what you said, by the way. That junkyard for you is your playground. That's actually where you discover. It's not that it's useless. I found that interesting. And then also that some basic animals have more DNA than us. Ours are just more effective. The teamwork is better within that. I thought that is a nice metaphor for how organizations should work. But I wanted to pull one of the mutations because you said there were probably several mutations that led to our relative hairlessness compared to apes, our distant cousins. We developed sweat glands, a more effective cooling system that allowed hairy archaic hominins to run farther, hunt better, and escape from predators more effectively, meaning they lived longer and had better odds of reproducing. Archaic humans with genes predisposing them to hairiness, on the other hand, less able to compete for resources and outrun prey, died out. I thought that was absolutely fascinating.
Yeah, so if you compare apes to humans, one of the things that really stares at you is the hairiness, right? I mean, we are naked apes, and apes had fur. So one question that evolutionary geneticists or anthropologists have for a very long time is, of course, why did that happen? What actually happened? And why did we lose our hair? Isn't hair a good thing? We need clothes now, but, probably in the past, we didn't really have as fancy clothes. We had to hunt animals to get their fur. So why didn't we keep our fur ourselves? And one hypothesis is that this is because humans changed about 2 million years ago, roughly starting. We became actually the really upright walking ape that we are today. This hominin that is really well adapted to walk on two legs. Unlike apes that do knuckle walking, right? They walk on all fours. And this interesting change, some people have suggested, has something to do with an adaptation that allowed humans to do long distance running. So something that people are not really aware of, but humans are incredibly good in long distance running compared to other mammals. In fact, we are the world champion among the mammals in world distance running. No other mammal can run 100 kilometers. They just cannot. They die. Like a horse, if you run it for 40 kilometers, it just breaks down. It dies because it builds up too much heat. It doesn't produce enough sweat to get rid of all the heat that the body produces. And humans have something that apes don't have as much, and that is sweat glands. We're really good in sweating. That is something that basically the hairs have been replaced by sweat glands. A lot of those, basically what used to be hair in an ape became sweat glands in humans. And a whole body, if you look at a runner, right, if you run, a whole body sweats. And that's something like, if you have a dog, for example, you know that he has to give out the heat through its mouth. They cannot sweat under their pelt. They cannot do that. But we can, our whole body just gets rid of the heat by sweat glands. And that is something that adapted. So just one of many other things. There's a whole chain of things that adapted and changed to probably become really good long distance runners. And then the question is, why would that be? Why is it good to be a long distance runner? And the main reason is, if you think about, humans are an incredibly weak mammal. We have no claws. We have no large teeth. We have no large muscles. If you compare, that to a tiger or to a lion, or even to a large gorilla that has huge muscles, we don't have all that stuff. We have a good brain. That's good. We can build weapons, which we do now. But in the past, like 2 million years ago, we didn't build weapons that were really complex. If you look at the weapons that archaeologists find, they're a chunk of stone, right, that you could hit on somebody's head, but it wasn't really a kind of sophisticated bow and arrow or like some kind of more advanced spear or something like that. So those things have evolved later. So what early on seems to have evolved is this long distance running. And then the idea is that long distance running allows you to actually hunt down animals, to follow them over quite a long time. And at some point, to them, it happens what happens also to the horse. They just collapse because of overheating. And if you can outrun them, if you just chase them again and again, even though you might not be as fast as an antelope, but you can track it in the savannah, for example, you see it where it is. You have really good eyes. Humans also have really good eyes. And then you just follow it. And at some point, it just drops over. It just hyperventilates. You just take that big chunk of stone, you head it on its head, and you have a big bounty of meat. And that is something that seems to have evolved during that time. At least that's a theory. That's something that geneticists can't really say, because it's more kind of like bringing a lot of kind of lines of evidence together. That's what evolutionary anthropologists have suggested. It's more like a hypothesis, which is not super easy to test, but I think it makes a whole lot of sense. So Dan Lieberman, who's a professor at Harvard, he has been really doing this pioneering research and has suggested that like long distance running is one of the driving factors of human evolution. And I think, for me, it just is a wonderful theory and kind of really makes a lot of sense given how our body is built. And that also then finally allowed us to develop a big brain, because the brain itself is a very expensive tissue. It uses a lot of energy. It uses about 20% of your metabolism energy, and it's only 2% of your weight. So it's a really expensive tissue. To feed it with enough energy, you need basically energy-rich food, and then you need to somehow become at least partially a carnivore. And not a pure carnivore, of course, but like an omnivore, where you just can't just eat plants to get a big brain. As you see, if you think about herbivores, they all have small brains, except of carnivores. They usually have the bigger brains. And that's what we needed, and that was our way to become, be able to hunt without claws and without big teeth.
I love this, man. I was thinking about how it was like a chain reaction of events. And this just shows how amazingly adaptive all life is. We're amazing, really, how we adapt to both the environment as well. Because a part you talked about, I was like, wow, it was a light bulb moment, was we moved when we started to evolve and we moved towards the savannas, we evolved to be more upright. Because we evolved to be upright, we could move more efficiently, we could run more efficiently. As you said, then we could hunt the animals. Because we hunt the animals, we could eat the meat. And then later on, we had Richard Wrangham on the show before with his book Catching Fire, and he talked about actually when we could cook the meat, we outsourced digestion, so our guts changed shape, and we exchanged stomach tract for brain stem, and the brain started to evolve. And because we had the brain evolution, we became more intelligent, we became better hunters. I'd love if you took us through that chain reaction of events that happens so often, as you've seen through your studies.
That's exactly like you say. I mean, you've already described a lot of those processes and those steps that happened, and eventually, when we could, like you said, outsource basically the digestion of the food by cooking it and having more access to high nutritious food, by becoming smarter and smarter, being better and better hunters, we then just evolved a bigger and bigger brain, and it was like a chain reaction. You need to feed that brain with energy, but it also allows you, of course, to be smart and find and gather food. That's the other thing. I mean, the one thing is the hunting, the other thing is the gathering. We've also become really smart on finding lots of things in nature that provide us with the nutritious food that we need to feed our brain, right? So gatherers are also quite amazing what they find in nature. If you see some documentaries about Aborigines, how they dig up things in kind of what looks like a desert, but they actually find water, they find food, they find insects, they find all kind of things that provide us with enough energy as we need. And I think this is also something that came with this kind of chain process that basically was still ongoing, maybe even for the last 10, 20,000 years, when we finally transitioned from hunting and gathering to agriculture and a sedentary lifestyle. When we settled down, when we built villages, when we domesticated animals and plants and developed this amazing civilization and culture that we have now, it's a glimpse of our evolution, right? It's like 7 to 10,000 years. That's nothing compared to 7 million years of human evolution since we diverged from the chimpanzee lineage. And it's still ongoing, right? I mean, culture, our brain that kind of allows us to have this complex culture and kind of accumulate all that knowledge, which no person can accumulate in their lifetime, but because we can just pass it on because of course, complex language, and then writing and accumulating knowledge. Now even the internet that kind of gives us, in our pocket, the whole knowledge of the world. We carry it around with us now, which is even more exciting. I think it's a constant process of, in a way, cultural evolution. It's not biological changes. I think our kind of physical appearance hasn't really changed for 2 million years. If you see a Homo erectus next to you, you would probably not notice it immediately that it's a Homo erectus.
Depends on where you are. Depends on what bar you're in, Johannes. I'm sure
and
you saw
how much pint you had. Yeah,
exactly. Johannes had an experience, studied in UCC in Cork. You've seen a few Neanderthals back then, I'm sure. So,
indeed, the Neanderthals surprisingly are actually easier to recognize than Homo erectus, because that's what a lot of people don't know. But Homo erectus looks more like us than Neanderthals do. Neanderthals are equally distant to Homo erectus like we are, even though, of course, some Europeans exchange DNA with Neanderthals. So we have, people outside Africa, all people outside Africa carry some Neanderthal genes. So in a way, we are a bit closer to Neanderthals than we are to Homo erectus. But Homo erectus, anyway, already had this body build that we had. But what really changed through time is kind of the brain evolution, and kind of the brain got a bit bigger, but also, I think, better organized. And our culture kind of changed, really. And on one hand, at some point, the kind of track of kind of natural evolution, biological evolution, became more and more cultural evolution. Because if you think about it, humans that live on the planet today diverged about 250 to 300,000 years ago. So say the deepest split within modern humans, like the San that live in South Africa and people outside Africa, they have a common ancestor some 200 to 300,000 years ago. So really long time ago. But they are as complex in their culture and in their abilities. If they grew up in Washington or New York, they can become, president of the United States or whatever they want, right? So it's not that their genetic makeup is somehow, in that way different to the makeup of people from China or people that have their ancestors in Central Europe. So at least for the last 250,000 years, it's not genetic changes, not our kind of evolution on that level that really made a big difference happen, but it's really more the cultural, the innovations that change, right? Which in the one hand is wonderful, because we have this amazing ability to kind of shape and change the future with this kind of cultural changes. But it's also tells us how weak we are without the others, right? We need this kind of larger sum of people. If you send two humans without much knowledge on an island, they will not build up a civilization. Like you sometimes see those computer games or something like that. They'll probably die, because we don't inherit knowledge. We need to learn it, right? We need to learn everything. Basically, we get born as an embryo, right? We are very immature when we get born, and like, say, other mammals, like an antelope that like plops out of its mother and like runs away from the lion or something like that. We plop out of our mother and we can't do anything, right? Our brain is tiny. I mean, it's like incredible, actually. We need to learn everything. And that makes us also very important on learning and kind of culture and kind of our social environment. So without that, we are nothing. And that's also important in a way. Our evolutionary makeup, our building plan is actually not worth much without a cultural environment and the kind of social environment.
So back to the timeline, because the timeline's fascinating, and it filled in many gaps in my knowledge, because when I thought back to my childhood, Johannes, even, I saw some movies, and the movies are like, they don't answer the gaps because they're Hollywood movies, so they're made for entertainment, not knowledge. And you talked then, at the time here, Europe was in the midst of genetic upheaval. The Ice Age intensified and the shrinking population coincided with a nosedive in the variety of European fauna. Some 36,000 years ago, Europe's animals underwent a strange mass extinction. Mammoths, bison, wolves and cave bears were all affected. Hyenas vanished without trace, and in their place, their Eastern European and North Asian relatives. And again, with new animals came new people, because the environment impacted the organism. I'd love if you took us through this period.
So this is a very exciting time period that we're now doing even more research on. We just published some papers just in the last couple of weeks on that topic, on kind of the first people that came to Europe, first modern humans that came to Europe. So the first humans were in Europe like 2 million or 1.8 million years ago. The oldest remains are from Georgia, which is, you could say that's West Asia or it's Europe, but it's not too far away in the Caucasus from Europe. And then there were different hominins here. Homo erectus was here, Homo heidelbergensis was here, Neanderthals were here. And then we came, modern humans, Homo sapiens, about 45 to maybe 50,000 years ago. People left some unknown place somewhere close to Africa or maybe inside Africa, and came to Europe, Asia, and Australia. And basically, within very short time, moved into this large landmass, Eurasia plus Australia, and settled those places and replaced the other humans that were there, like Neanderthals or Denisovans or Homo floresiensis in Southeast Asia. All those people got replaced. All those earlier human forms got replaced by this new population of Homo sapiens that was, for whatever reason, special. We're still not sure. It's one of the biggest questions, one of the driving questions of our institute. What makes us so special? What makes humans humans? Why are we modern humans better than all these other people that were there before, like Neanderthals, Denisovans, and other types of hominins? And we were somehow special. But what's also interesting is if you look at those very first people that came to Europe, some 45,000 years ago, we now know they got extinct again. They came here, they settled here, and then they disappeared. And then they came again, and they settled here, and they disappeared. And only from about 37,000 years ago, you have a genetic continuity with later people. So it really took like 10,000 years of unsuccessful trial and error to come here, settle down, and then disappear again. We're not quite sure why that is. Maybe it was climate, maybe there was some climate fluctuation, maybe the animal populations also declined because there's some big climatic changes. There's big volcano eruption about 39,000 years ago that affects at least Eastern Europe very strongly with a thick ash layer. It's one of the biggest volcanic explosions over the last 200,000 years that happened. It's actually from close to Naples, so one of the large volcanoes, which is part of the Vesuvius Massif also. And that exploded and just had a huge impact on Eastern Europe. And then probably that wiped out animals and humans in that part. And then kind of new people came in, and those are the people that then have genetic continuity with the later populations. And then there's different ice age populations, different hunter-gatherer populations, the mammoth hunters, they're sometimes called, because they were living in an environment during the ice age where there was a big mammoth steppe. So it was a big grassland, Europe, and you had those large animals, like large megafauna, like you had woolly rhino, you had woolly mammoth, you had horses, bison, reindeer, you had large, all kind of large animals, and of course they're predators as well. You had cave lions, you had hyenas, you had cave bears, all things you can't really think about when you live today in Central Europe. You know, this all sounds like some sort of Jurassic Park, but it was all here just until 25,000 years ago. And the early modern humans that were here, they were really good in hunting those animals. They were living as part of that ecosystem and environment. They were hunting large animals. They were even building houses out of their bones. It's really impressive. In Eastern Europe, you find those massive houses, like huts, like nomad huts, but they were built of mammoth bones. It's like super impressive. And they were quite successful, even during the Ice Age. But at some point, it became too cold. About 25,000 years ago, Europe becomes super cold. Basically, there's a glacier that covers like Berlin, right? I mean, it's really come from Scandinavia, comes all the way down to Berlin. And Central Europe is so cold, nobody can live here. And that's called the last glacial maximus. The last is the kind of the coldest period of the last ice age that wipes out most people in Central Europe and West and Eastern Europe. Only in Southern Europe, people can survive, like in Iberia and in Italy and the Balkan Peninsula. And then after that, when it gets warmer again, 15,000 years ago, the glaciers retreat and humans come back with a bit of a different genetic makeup and surprisingly with a different phenotype, because suddenly they all have blue eyes. We're not quite sure why that is, but before that, they all had brown eyes. And after this kind of period of glaciation, they all have blue eyes. So it's a bit like Game of Thrones again. They all become some sort of White Walkers or something. Not quite that, but for whatever reason, they all have blue eyes. And that's the blue eyes we still find in Europe today, by the way. So it's that mutations that have risen in frequency then. And those repopulation of Europe then gave a high frequency to those blue-eyed people. But dark skin, in fact, which is also interesting because the light skin that we have in Europe today only evolved much later. So there were dark-skinned people with blue eyes that were the kind of Central European then population, but also, of course, in other places in Europe as well. When the glaciers retreated, they moved to Great Britain, then into Scandinavia about 10,000 years ago, and into the Baltics. And whenever those areas freed up from ice and were hospitable places, then people moved in. I mean, that's usually what people do. They settle everywhere where they can reach and where they can build a house and have some sort of subsistence and they have animals to hunt and food together. They will actually move in there. And there was a general pattern that they did. Eventually, also, they were able to find America because there was this large glacier that was sitting on top of the Rocky Mountains, which was like a barrier. You couldn't penetrate that glacier. But then 13,000 years ago, it starts melting. And then there's a corridor and they just went into the Americas. And within 500 years, they make all their way from Alaska to Chile, right? They cross the whole two continents, North and South America. They settle North and South America. And then the population expands within very short time. I mean, humans are very good in reproduction also. And maybe that's even one of our kind of biggest strengths, that, you know, humans can have 10, 15 babies if they really try hard. And, you know, prehistoric populations, even historic populations, if you think about maybe your ancestors, you know, grandparents, they had like 10 kids, 15 kids. That was quite normal. I mean, I think you're from Ireland. I think they still see kind of those images from the 19th century with those large Irish families, right? I mean, this was quite normal. And that's something that, of course, allows over several generations. If you have, you know, 1,000 ancestors, they all have 10 children, right? Then it's like you can make a large population of millions of people within a very short time. And that happened in a lot of places when basically something was available to be settled, like also in the Pacific, kind of little islands somewhere in the ocean, and everywhere in the world was colonized.
Man, where do I go now? Because there's you've planted so many seeds. I was thinking, maybe we'll take care of the skin color, because you mentioned eye color, because skin color was very much dependent on where you lived. And let's bear in mind as well, we came from a common ancestry, and then it depended on where you live because of vitamin D, for example, from the sun, for example. So the more Nordic areas, the paler your skin, so you can take in more sun, etc. Perhaps we'd share some thoughts on this, because we had Angela Saini on the show a few weeks ago, and she was talking about the science of race culture and segregation, for example. I mentioned your book to her. She said she'd read it. She loved it, by the way. But this is really important because it debunks all those things about superiority, for example.
The skin color is actually a very interesting trait because, people have used it to define human population or races, right, in the past based on pigmentation, which is, first of all, totally bizarre because there is not white and black, right? It's not that there is, like on a chessboard, that those people that are completely white and those people are completely black. I mean, if you've ever been in a pharmacy and you look at all the shades of kind of tones that all those products have, there's like thousands of them. There's thousands of shades of skin color. So how could you say there's white and black? It doesn't make any sense. If anything, it's a gradient between like pale, maybe kind of Scandinavian type of people, and people that live in Central West Africa that have a very, very dark skin. And in between, you have everything. And at no point in the world you can say, between this village and this village, this is the border between white and black. That doesn't make any sense because it's a gradient, right? It's like people that even today kind of define races, based on biological terms. They use people from very different parts of the world. And like in North America, you have people with a European origin, with a West African origin, with an East Asian origin. If they meet all in a room and they have only the ancestors from those places, you easily notice, yes, they look phenotypically different with their kind of different shades of skin color or kind of also maybe eye shape or something like that, or eye color. But if you would see all the people in between, you wouldn't even say, where can I cut this kind of into different groups? Because it's not, because it's a gradient. It's like a color gradient where you take out 3 different points and then you see they are different, but actually it's a gradient in between. And it's a very important message also for the genetic variation that we have today. It's a gradient. There's no races in biological terms. They don't exist at all, because first of all, we are very recent. We have only diverged from Africans 50,000 years ago. East Africans, as we said earlier, are closer related to Europeans and Asians than to West Africans. So if anything, people outside Africa are East Africans. We're an East African tribe. What does it make then Africans, right? They have more genetic variation than all people outside Africa by far. It's the stem. If you think about a tree, it's the stem of genetic variation that we have in modern humans. And the thickest branches are all in Africa. So the deepest splits are all in Africa. So we are just a tiny little branch outside Africa. So kind of then saying Africans as one group is totally wrong, because it's so many groups, it's so many different kind of genetic populations that are, of course, connected to each other, but they are kind of very deeply rooted and very deeply split from each other. So it really doesn't make any sense. But then this other thing, the skin color itself that people use to define, the white race or something like that, it is actually something that's very recent. It's only about 5,000 years ago that Europeans are white. Before, like 10,000 years ago, if you go back to Europe, you see any European, he's black. He's like, genetically, we cannot say that they are different from people south of the Sahara, so sub-Saharan Africans. We're not quite sure how dark they were. Maybe they were a bit kind of lighter than sub-Saharan Africans, but certainly the white color, the genes that we know that cause white skin, that cause less pigmentation, that are fixed in, say, people from Scandinavia or Central Europe today, that are so typical for Europeans, giving them their light skin color, they only emerged less than 10,000 years ago, and they spread only widely 5,000 years ago, during the time when people changed their lifestyle from hunting and gathering to become sedentary farmers. And farming is really what changed our skin color. And that's the amazing thing that we found out over the last 6-7 years of research. It was not coming to Europe. It was farming. Because people came to Europe 50,000 years ago and they were dark because they came out of Africa, right? They had dark skin because they were Africans. In Africa, you need dark skin because the sun is so intense, which everybody knows who's ever been in Kenya on the beach without sun blocker and who's from Central European heritage. Absolutely, he would they would burn their skin, right? I mean, you cannot live there. You would actually die, in fact, over a long time. And you see it in Australia, where 20% of the population have skin cancer today because they are from Britain, many of them, in their genetic heritage, and then they're male adapted. They're not well adapted to live on the equator. They're not really good, so they need sun blocker, which helps today. It's a cultural innovation that helps. But if you would give them 10,000 years of, say, natural selection and evolution, all Australians would actually become dark skinned, right? Because that's the right adaptation you should have living there. But then a lot of people then thought, okay, then people came to Europe 50,000 years ago, so they became white because they didn't need the dark color anymore. But that's of course wrong, because it doesn't go that fast that you lose something that you have gained before. Because if there's no gain to be lighter pigmented, then you wouldn't become light. There needs to be some sort of advantage of becoming light. But then there are populations that live, say, in northern Siberia, that live in Greenland, like Inuit, for example, Eskimos. Those people, they have actually darker skin than people in Scandinavia, but they live high up in the north. They live higher up in the north than people in Europe. So why are they not light if it's so advantageous to be there? And that's just because of their food. They hunt. They eat a lot of meat. And in meat, you have actually a lot of vitamins like vitamin A, vitamin D. And vitamin D especially is something that otherwise, if you don't get it from food, from fish and from meat, you can get it from sunlight, right? So if you live in a place with little sunlight, you don't produce vitamin D in your skin through the sunlight, but you can actually have it by supplements. You can eat it. Like today, you can go to the supermarket, you have vitamin D products, or like in North America, they put vitamin D in milk. So nobody is deficient of vitamin D if they take those products. They don't need the sunlight, so that's fine. But hunter-gatherers also don't need it because they eat fish and meat, so they don't need it. So naturally, those people, like also the Europeans until 10,000 years ago, they didn't need vitamin D produced in their skin. They could have dark skin color. But then something changed, and that was we became farmers. And farmers 5 to 10,000 years ago, they were more or less vegetarians. They didn't eat meat. Today, you think about a farmer like, oh, he has a sausage and eats his pork or chicken and beef and what have you, but not in the past because they didn't eat their oxen because they were their tractor, right? They used it to plow the fields. They didn't eat their cows because they produced the milk that they needed maybe for nourishing their 10 children or something else, but they didn't slaughter a lot of animals. They didn't eat a lot of meat at all. And becoming a vegetarian and living in Northern Europe, that was just not possible. That was strongly selected against, because if you're a vegetarian and you live in Norway, you will have massive problems in the winter with vitamin D deficiency. If you have darker skin, it becomes even worse because you cannot produce any vitamin D in your skin because there's too little light, there's too little sun that penetrates your skin and produces vitamin D. So you have to get supplements, but if you don't have a supermarket like 5,000 years ago, something has to change. And what changed is people became white. So there was a very strong selection for lighter skin color from the moment on people started farming in the northern part of Europe. And it's actually interesting to see that farming started in Great Britain and in Scandinavia quite a bit later than in Central Europe, even though it was there, but it took some time to move up north. And in fact, Finland only changed into farming 1,000 years ago. So it was really, it took some time for people to adapt. And I think one hypothesis could be that this is because of, they had to adapt also in their skin color, because that's what we see. We see them changing in their skin color over the time period. That about 4,000 or 5,000 years ago it starts, and then about 3,000 years ago, most people carry the genes that we know today give kind of light pigmentation, that give a lighter shade, and especially in Scandinavia. And it's another question that people have, like, why are Scandinavians so white? Why do they have so little pigmentation compared to the rest of the world? But there's also a very special place, Scandinavia, because if you look at the world map and you look where Scandinavia is in the world map, it's by far the most northern part of the world where people are actually farmers. Because nowhere on the other parts in the Northern Hemisphere, you can actually do farming in those high latitudes. It's high up in the north. If you compare that, say, to North America, you're north of the Hudson Bay, right? Or in Asia, you're like deep in Siberia. But just Europe is so special because we have the Gulf Stream that brings all the warm climate to Europe. And so therefore in Scandinavia, like in Norway, in some parts you can have palm trees in the gardens, right? People actually have agriculture there. Same in Scotland or even Iceland, which is so far up north, is actually a pretty kind of, it's not a super warm place, but still people can have agriculture there. And that is something that is just not possible anywhere else. So they live by far furthest north. So they had to adapt more than, say, people in Asia or people in North America, where there's just no farming. You had to be a hunter-gatherer to live so far up north. And that's why the Scandinavians became the whitest people on the planet, right? That's at least the best explanation that we currently have.
I love it, man. And it made total sense to me. I thought about flamingos, and they get their pink color from the shrimp they eat, for example. And I was like, that makes so much sense. And then you add the environment in and the sun and the adaptations, etc. But I thought it was really fascinating because this is the kind of, you colored in so many missing links for me as I progressed through the book. One of them was the split between hunter-gatherer and farmers, dependent on the environment, which like totally makes sense when you read it, but I hadn't pieced it together before, because it then gave way to ownership of land, because farmers were constantly looking for land that was good for farming, but a hunter-gatherer could really just explore. They didn't do storage, so they just kind of moved around and they roved a little bit more. But then also on top of that, they migrated towards places like forests where they could fish and they could eat meat, etc. But this split started to create changes in ownership because the farmers wanted to own land, and that started to change how people thought about land.
It was probably it's the beginning of inequality, right? So the moment that people put kind of a claim on land, it means, they claim they own that, right? And like hunter-gatherers don't have that concept even, because they just have the landscape. They're nomads. They move, right? They don't own the mountains. They don't own the rivers. They don't own the forests. But then that's just a hunting ground, right? That's like they put their tent here. They put their camp there. Maybe they kind of stay over winter somewhere in a cave. But they really don't have the concept of, I can own the world, right? That doesn't make any sense to them. But then, of course, farmers have that because they need a plot of land and they want to inherit that plot of land to their children, right? Now, if they have 10 children, like they probably had in this early farming period, they cannot inherit it to 10 and divide it by 10. So they rather say, okay, my oldest son or my oldest daughter gets that plot of land. Now the other 9 go in all kind of direction and plot another piece of land for themselves, claim it. That's the expansion. That's what we call a Neolithic expansion. That's basically the moment people came up with agriculture. They expanded everywhere because they needed fields of land. What they also do is they have storage, right? So people they then harvest, they keep their grain, they accumulate, which is good for them because they need it for maybe kind of a hard winter or maybe some season where it's too rainy. You cannot have a lot of new harvest, so you basically store things over time, and then wealth basically accumulates. Some people had more fertile soil than others. Some people had a better plot of land or a bigger plot of land or just next to a river. So some people had more accumulated than others. Some people became more powerful than others because eventually there was no more land to be plot. So the people that had kind of claimed the most had also kind of became the richest, right? And then there also became this kind of power inequality. And of course, that started conflicts. And then, some people just went into warfare, right? They just said, okay, then we go to the neighboring village. We just take the women, we take the land, we kind of slaughter everybody. And that's what we see starting from the time that agriculture, especially, we have mass graves, hundreds of people being killed by another group of early farmers. And that's really when basically things are not equally distributed anymore. And that starts conflict, that starts inequality, that starts the patriarchy, which we think we see in our genetic data, that we suddenly see that only men inherit farms from their fathers and women actually have to leave the farm, as far as we can say from the data we have from the late Neolithic and from the early Bronze Age. So people have a claim on that land. And then, of course, the more powerful people want to secure their power. At some point, you have probably some sort of leaders, you have some sort of lords, you have, early kingdoms, and this all emerges, but it's all part of this kind of early transition from owning something and accumulating to just gathering food for maybe the winter or for some season or for just survival, but you could never accumulate much more than what you could carry, what you could bring somewhere, because you didn't have a big house, you didn't have a castle, you don't have some storage facilities or so, hunter-gatherers, but this was really kind of, much more equal societies than what you had then in this transition to farming and to agriculture. That really made the big change. That's basically a lot of the conflicts that we see in the world today that maybe accumulated in world wars and atomic bombs basically have their groundwork laid in this transition, because for 7 million years we were hunter-gatherers and we were not always friendly. I guess there were also conflicts with people. We see Neanderthals eating other Neanderthals, or we see also kind of hunter-gatherer tribes fighting and probably also killing each other, but to a much lesser degree of what we can say compared to what we then have in those early farming societies where we have mass graves and warfare. And then in the Bronze Age, we have really deadly weapons. Metal basically kind of replaces stone technology, and then people become even more good in killing, and they just don't only hunt and kill, but they then also mostly what we see in the Bronze Age is just weapons for killing people. Right? Those are not weapons for hunting, for a boar or a stag or a deer, but it's really for people, like a sword, like a sword that is really short, that you will not use that for killing a boar. You will just use it to stab somebody. And that just emerges then when the metal ages start and warfare becomes really a big thing, right?
Johannes, are you okay for another 15 minutes or so?
Sure, yeah.
Ah, brilliant. Thank you, man. I usually don't go on so long, but I have there's so many questions. And I said I didn't even finish because I'd written so many notes. And I've been using this technique where I write the notes and then I read over them every day. So I kept accumulating kind of knowledge that way. But there's a couple of things. One was I wanted to get to the technologies we discovered. So one was the wheel, and we often see this in innovation, for example, where it's like, hey, why don't you try this wheel? There's a cartoon, and then the other caveman's like, I'm too busy. But the wheel was an amazing technology for us for many reasons. But the other was the horse, and I often think about that quote by Henry Ford. If I asked people what they wanted, they would have said a faster horse. But originally, we didn't even have the horse as a mode of transport. These two technologies were remarkable. One, I thought about the wheel, because the wheel meant that using oxen and then using them to pull carts was interesting, because it meant we didn't have to be the travelers. But also it meant that people would also dominate land. In other words, pull down trees, pull big rocks out of the way, flatten the land, create more land for farming, which meant an expansion of territory as well.
Animal domestication itself is amazing, right? That you suddenly have a source of milk, a source of meat, and you have a tractor, right? I mean, we didn't have machines until 150 years ago. So like for the last 9,000 years, we were relying on animal traction, right? That they actually, pulled our stuff to plow the field or pull out, like you said, like the big root of a tree. Because the one thing is you can chop down a forest, easy, right? Probably all of us can do it if you have a good axe in a couple of weeks or months. But then getting out the roots to have a land where you can actually have nice fields, it would have to wither away over decades, probably hundreds of years, until you could really plow the land. By that time, you have a new grown forest. So it's not trivial. So only when you have oxen, when you have really powerful animals, like a tractor, basically, then pulling it out would allow you to actually turn a forest into a field that you can have agriculture on. And those things, happened in the early Neolithic and were really important. But the other thing is what we just said, that, people also needed, wheels to kind of just move objects from A to B. And, you didn't want to carry everything. Of course, you can use animals also kind of for package, for carrying, for transport. But it's much more powerful if you have a cart where you can put a lot of goods on. And that was especially useful in the steppes of Eastern Europe. The steppes of Eastern Europe were in the past a place for hunter-gatherers to maybe kind of catch some wild horses or something like that. But they were not really good for agriculture, because the temperatures there, the hard winters, the strong winds didn't really allow much it's not so fertile, the wild kind of grass steppes of like Eastern and Central Asia, Eastern Europe and Central Asia. But they were really good for pastoralism. So for having large herds of animals like goats or sheep that could basically roam around. And if you could control them, you could actually, live from them. But that also meant they were mobile. You couldn't build a house, right, and have your kind of sheep around it, because then the grass is gone within a couple of days, and then you have to move on. So they had to find a way of transporting their houses. But of course, if you have sheep and goat, not really useful for carrying anything. You really want to have something to carry your goods, your household, basically. And then people, I guess, at some point in the winter could use the sleigh, which might work. But then, in the summer, you needed something, and just putting it on the back of a cow might have not been very efficient. So people came up with wheels and wagons, which was a super good invention, because it allowed the whole household to be moved on when the herd was moved to another place for pasture, and they just followed. They just followed the herds, and this type of basically, early kind of pastoralism was really taking on big time around 6,000 to 5,000 years ago in the eastern steppes. So the population expanded a lot. The herds expanded a lot, maybe even to a point where some people now think that they overexploited the steppe and actually destroyed it, because at some point around 3,500 years ago, they all collapse, or they're all gone. And it seems that the fertile becomes, that the soil becomes less fertile, and basically doesn't support kind of large grass meadows anymore. And probably they overuse that landscape. But then they move on to other places and become highly mobile, those people around 5,000 years ago, there's a culture called the Yamnaya culture. They expand to the east and west in all kind of directions. They go all the way into Siberia, into the Altai Mountains, and they expand all the way into Europe, into Great Britain, into Spain, into kind of all kind of places within very short time. And of course, this type of mobility and migration would have been impossible without the wheel and the wagon, because that's the only way how you can pull your house from A to B. And of course, the other important part of it was the horse, because eventually people learned riding and learned that horses can also be used as kind of traction animals, which of course oxen were stronger and better for those large kind of wagons. But then eventually horses replaced them, which I think made people then even more efficient, faster. I guess everything became a bit more kind of smaller build, because horses are not as kind of strong as an oxen would, for example, be. But then people also learned riding. And that, of course, made another big change, because when humans became riders, we became super strong, super fast. And even, until recently, until World War II or so, horses were still used as one of the kind of best kind of weapons in combat, because they were just a large advantage. If they were just used for warfare, they were, protecting the people, making them super strong. And the cavalry was a really, really important, basically military units that changed warfare 5,000 years ago, maybe starting for, until very recently, until we had tanks, basically. And that also made a big change. And that then allowed those people to expand even further. And then later time periods, you have the Scythians, you have the Mongols, you have the Huns, you have the Avars, you have all those kind of steppe riders that invade empires, that destroy empires, that are a big threat to Eastern Asia, to China, to kind of big dynasties in China, or to the Eastern Roman Empire, or to kind of Central European various populations. And they even settle, like the Avars in Hungary, and establish a kingdom and things like that. And that was all just possible with this horses, this kind of mobility that basically emerged. And there's actually a big debate where it happened. Some people say it happened in the steppe, that the wheels were first used. There's some evidence also from Central Europe, where at least some wheels had been used also about 6,000 years ago. But certainly the massive use really came with the steppe pastoralists, because it's impressive. I've seen some of the archaeological findings. They often come from a kurgan, so from a kind of mound burial mound, and then you see those riders sitting, buried with their wagon, on their wagon, with their rein, kind of basically sitting there with the horses or their oxen. This is just amazing. That shows how kind of dear it was to them, that they even took it into their grave, that their wagon and their oxen or their horses. So it certainly there was a very close relationship between them.
And one of the things I found really, really interesting was not just because we live in an age of gluten-free and lactose-free, but the fact that when I was a hunter-gatherer, for example, I could only have a certain amount of children, because I could only, when I was breastfeeding, I couldn't have another child because there was a limitation on my energy, etc. But when I became a farmer, when I was a hunter gatherer versus a farmer, the farmer could then produce more milk from the oxen. And in the early days, they could only, you were saying, for example, early cows had a lot less output of milk, enough maybe for a cup of milk for everyone. And the human body had an amazing adaptation for this, where adults they didn't have lactase, the enzyme important for digesting milk, but infants did. And this was in a way, to orchestrate a lack of competition for the scarce resource that was milk. But the fact that we had milk meant that farmers could have more children. The fact that they could have more children, there was more competition for resources. I find these cause and effect elements of the book absolutely fascinating.
Lactase is the enzyme that all mammals have to break down milk, because we are mammals, right? We do kind of breastfeed for the first, usually at least, humans maybe a year. For animals, depending when they get weaned, that can be after weeks or months. But all mammals depend on milk after they are born, which gives them just the nutrition that they need, because they don't have teeth or they cannot really yet kind of eat food. And the evolution has basically made sure that at some point this enzyme gets not produced anymore, because you want to protect the mother giving milk from, in a way, greedy children or, even adults, right? I mean, if you think about, if human milk can be used as a source of energy, or it could also be for animals, then in any kind of point where there is a famine or where there is, starvation or something like that, they would basically revert to kind of breastfeeding women and would take away that milk, which usually would probably mean that the children would die because there wouldn't be enough. But evolution has basically made sure that that doesn't happen. So at some point, you cannot digest milk anymore. You get diarrhea, like big time. You just cannot digest it, because what happens is the enzyme doesn't get produced anymore. The sugar is not broken down. So if you cannot digest the sugar, the bacteria in your colon, they can. And they have a big party, but you don't profit from that party because it's deep down in your guts where you cannot actually absorb it anymore. And it just causes fluctuation. And it's really not a pleasant thing. If you're lactase intolerant, if you're not lactase resistant, so if you don't produce it, if you're lactose intolerant, then you know what I mean. Fortunately, I'm not. I can drink a lot of milk, but a lot of people can't. Most people in the world, in fact, can't. Most mammals, like I said, can't. But then some, maybe only about 2,000 years ago or so, that changed. It's actually interesting. It's a very recent change that humans suddenly became lactase persistent. So they produced lactase still during their adulthood. And that happened in a few places in the world, in East Africa and India, as well as in Europe. And in Europe, it's actually very high frequency in Great Britain, as well as in Scandinavia. Not so much common in Southern Europe. So in, say, people that live in, kind of have their ancestors from Italy, they have a very high chance that they lactose intolerant. So only 30% of them are lactose tolerant. Whereas people that come from Norway or from Ireland or Great Britain, they have 98% frequency of being lactose tolerant. They can drink a lot of milk during adulthood because they have this mutation that started about 5,000 years ago to spread, and then really kind of was rising up in frequency some maybe 2,000 years ago or so. And it's really interesting that it happened so late, because people had milk much earlier on. So you would think, those early farmers, they had cows, they had oxen, they had plenty of milk. Like, why did it happen so late? There have been several theories, and one is that it was just because they produced more milk at some point, those cows, because an early milk, like an early cow that was domesticated some 8 or 9,000 years ago, compared, like say, to other mammals, they would probably produce about 2 liters milk a day. But if you think about a milk cow today, like the Holstein cow that we have in Germany, the black and white cow, they produce 50 liters of milk a day. So they produce much more milk. And this surplus of milk where you have to give it to the cow, you want to have it maybe for other parts of the family. You only had over the last maybe 1500 years or so. Even the 50 liters is maybe only the last 100 or 200 years, but say 15 or 20 liters milk a day per cow is really something that's a very recent kind of development. And that is something that only at that point, when you have so much milk, it's really a good additional source for nutrition. Because if you only have 2 liters and you have maybe 2 cows, half of that is given to the cow. If you have maybe 1 liter of milk, for the whole family of 10 children plus adults, everybody in the world can drink 1 glass of milk. That's not a problem. Even if you're lactose intolerant, you can drink a glass of milk. What you cannot do is drink a liter or 2 liters of milk. And it really made a difference. And I think only at that point, when there was so much milk available, it didn't happen. And one question then that people had is like, what about Italy? And where's it different to Ireland? Like, why is Italians 30%? Why Ireland like almost fixed it? They both have cows. They both do dairy. They have pasture. Today, obviously, they drink cappuccino only in the morning. If you've ever tried to get a cappuccino in the afternoon in Rome, they laugh at you because you drink milk in the afternoon. That's weird. You only drink milk once a day. It's very important in Rome because they are lactose intolerant. So that makes sense. Culturally, they have already adapted to it. And the reason probably is that in those places where the average temperature is actually higher, milk doesn't survive much long. So if you think about, an early farmer 5,000 years ago in Italy, he's milking his cow. It takes maybe 3 hours. Then you have some sort of yogurt-like product because it's not hygienic, right? There is bacteria, and the milk will just become, we would call it bad, but you could also call it cheese or ayran or yogurt or kefir or all those kind of wonderful products that people in the Mediterranean make out of cheese, right? Mozzarella. And that are all, most often they are fermented products because milk ferments from itself. Like when I was in Kazakhstan and people were giving me horse milk to drink, and they call it kumis, and it's like a wine, right? It's really sour and it really has alcohol inside. And I asked, it's just like, how do you make that? And they look at me like, what do you mean? We milk the horse. And it's like, and how do you make the fermented product? And they're like, we just wait for 4 hours, then it's fermented, right? It just happens from itself. And I think that's a difference. That does not happen in Scandinavia. That does not happen in Ireland. You milk the cow, the milk stays fresh for a couple of days because it doesn't ferment from itself. If you then want to drink it, you get all the lactose. Fermentation degrades the lactose. Those bacteria, they eat the lactose and split it up. So like an old cheese doesn't have any lactose because it's completely fermented. And that's also for ayran, for yogurt, for kefir, for all those products. Like my wife, for example, she is lactose intolerant. And we make kefir ourselves. So I put the milk and the kefir together and I wait a day, and then we have kefir, which she can drink, but milk she cannot. And I think that same thing just happened in a lot of places naturally because it's so warm. And in the cold places in Europe, in Scandinavia, it didn't happen. That's why more people are lactose intolerant. But it's kind of hard to test that hypothesis, but I think I'm pretty convinced that's.
I love it, man. I love it. On storage, there's a really interesting part. I thought about this, that cast your mind back to being in the Great Savannah. You're a farmer, for example. You have great open land. But now you start being able to mass produce crops. You start to be able to store things versus a hunter-gatherer who can't. And I thought about how, in an age of the pandemic, people can meet in open spaces that's outside, but they can't in close confinement. And the same thing happened back then. So once I had a store, I attracted vermin. The vermin then carried parasites. And it was an age where hygiene was a foreign thought. What didn't dawn on people. They were unaware. They didn't have the intelligence to even think about it. But this led to the spread of pathogens and lice and disease. And migration then spread it throughout the world. And we're running out of time, Johannes, but I'd love you to share how the origin of pathogens and human disease happened, and how we've always bounced back. I mentioned this in the intro. We've been wiped out by epidemics, by pandemics over the years. There's DNA. You've shown this in some of your research, but we always come back. And I think it's a really positive message that comes from your book, that we need migration because migration spreads knowledge. Migration is important to the success of the human species. And B, when disease happens, we're very resilient. We're brilliant adapters. We need to refine and rediscover that adaptation muscle that has maybe atrophied for a lot of us. But we have a very positive future.
I mean, first of all, in terms of the kind of spread of pathogens and the emergence of most human pathogens, that is really, as far as we can say from our research, starting massively during that time when we start settling down. And there's multiple reasons why the transition to farming introduced pathogens in the human population. The first reason is we became sedentary. So we had houses. So where do you dump your stuff, right? Like often very close to the house. And that attracts vermin, that attracts all kind of animals. And it also means exposure to excrements and all kind of things. Feces might be close in the environment where you live for a very long time and things accumulate. So that's probably pretty bad. Also, the population density becomes higher in those villages, right? If you have a disease that you have caught somewhere from an animal or somewhere in the environment or from another person, it's much more likely to pass it on to somebody than if you're a small tribe of like 10, 15 hunter-gatherers that is living somewhere in the kind of woods or in the countryside, but you might not actually easily spread it between other groups of hunter-gatherers. So the exposure, therefore, is higher. The dissemination is much more likely. And over time, it also becomes evolution because those pathogens basically discover humans as a new host because our population size was increasing more and more. And suddenly those pathogens, which were maybe kind of restricted to certain animal groups like cows or kind of hare or mice or kind of other animals that live in herds or larger groups, they suddenly see, oh, there's this new mammal that lives in large groups and actually is well connected and becoming more and more globalized. And like, look, this is the perfect kind of host that could easily spread us all over the world. And that's what evolution does really good, right? It's kind of reproducing, and if there is a new niche, to explore it. And humans became the new niche, right? That was really exciting. And we've seen it over the last 1.5 years of the pandemic. I mean, this new virus emerged sometime in November 2019, jumped into humans, and within several months, it was in every country in the world. And by now has cost millions of people's lives and has spread into hundreds of millions of people probably. So it's really incredible that in so short time. And that already started, but it did start at the moment when people became sedentary farmers. And it wasn't there before. And that really made a big difference. And then all kind of pathogens became human adapted. We have all kind of examples of the emergence of human pathogens, type of measles, smallpox, the flu. We have later on the big plagues, right? We've done a lot of research on the emergence of Yersinia pestis, the causative agent of plague. We looked at how plague affected human history, and it has been, rampaging through some time periods, causing mass, basically, breakdown of civilizations and probably killed half of the European population in some of those large pandemics, like the Black Death in the medieval time, and other things like smallpox and measles were probably as bad in earlier or later time periods. But yes, humans are resilient. Humans do recover. Humans have been very good in kind of still managing despite those time periods of devastation. I was born in the 20th century. It was a time of, we started the century with a world war. Then we had a big pandemic, the Spanish flu, killing 70 million people. Then we had a big economy crisis, making millions and millions of people unemployed all over the world. And then there was World War II, which was, almost, you could say, the kind of biggest catastrophe of all, with atomic bombs, with, also again, 50 to 100 million people dying and people being forced out of their homes, and concentration camps, and the Holocaust, and like horrible things that happened in the first part of the 20th century, and there many more bad things happening in the later time. And now we're again living in a pandemic, and we still have wars all over the world and conflict. But at the same time, I'm also seeing how humans have, doubled their population since 1970, right? The amount of poor people, of starvation, of starving children, of crime, of rape, of murder, of violence have decreased massively over the last 50 years. We sometimes don't see of all the bad news we see in television that we under the impression the world is a horrible place, some sort of apocalyptic kind of science fiction scenario. It's not at all. Most of us live in peace. Most of us have enough food on the table. And that's never been as good in human history. So if somebody asked me, if you have a time machine, where do you want to travel? Where do you want to live? If you could choose again, you get reborn. What time period would you want to be reborn with? I'd say now. Now is the best time ever in human history. And I really studied human history in depth. I think there's never been such a stable time, at least in Europe. And of course, there's some places where there's war, and there's lots of places where there is still inequality and there's problems. I mean, I'm not saying the world's a perfect place, but the world has become much better over the last decades compared to the past. And it's actually kind of a progression, I could even say, for the last couple of thousand years. I don't want to be born in the Bronze Age. I don't want to be born in the Roman time. I don't want to be born in almost any time period, right? I certainly would like to see dinosaurs walking on Earth or something like that, because I'm generation Jurassic Park. But in terms of human history, I think I just love to be living at that time that we live now, where people have enough food, where they have vacation, where they live in beautiful homes, where they have, a hot shower in the morning, where they have heating in the winter, where they have enough food everywhere. And it's like that's true for a large part of the population in the world. And that's never been like that before. I mean, also, if you go, some people still have the impression in China, they live like 100 years ago, something like that. They don't see that Beijing looks like Manhattan. They don't see, if you go to India, that, there's also kind of cities that are, as big and as developed as in any other place in the world. The same is true for Africa. Of course, there is still a lot that has to be done, but I think humanity is on a good track. And of course, there are threats like climate change. There is threats like diseases, like pandemics. There is, still the nuclear threat, right? There's still 14,000 nuclear warheads in this world that could pulverize the entire planet if they would all be detonated, which is probably the biggest threat, I would think, to humanity. But in the same time, we have done well, and I think we will keep on doing well. And I think our culture, our big brain, will solve problems. And I just hope that equality will become even more pronounced like it was. But if I just look at the last 50 years, if we progress like we do, and now the European Union saying, by 2045, we want to be basically not producing much more carbon dioxide into the atmosphere. By 2030, we want to have 55% reduction of carbon dioxide emissions. I mean, my God, think think back 10 years ago, if anybody would have said that, they would have said, you're crazy, that will never happen. But now, yeah, it will happen. I see windmills everywhere. I see regenerative energy everywhere. I see much more equality. I see much more diversification, people from all kind of backgrounds being in all kind of positions. And I think the world is on a good track. And there will be throwbacks, and there will be maybe another pandemic and another war. But I think overall, I think we're doing quite good. And I just hope that we can use the resources that are given to us on this planet to the good of everybody. And we have become better in that way over the last 50 years. And I just hope that this trend will continue, and it will not just basically provide a good life to a few, but actually a good life to the majority of people on this planet.
Beautiful. What a brilliant way to finish today's show. And just a reminder to our audience, I have a copy of this brilliant book. It's so comprehensive and so well written. I have one up for grabs. Just sign up to the innovationshow.io newsletter and you'll be in with a chance to win that. Johannes, for people who want to find you, more about your work, those papers you mentioned, where can they find you?
I mean, they can just Google my name. We have a webpage with lots of publications, but these are mostly not accessible, I would say, to the public, because they're kind of genetic papers. They're quite more detailed maybe than what we write in the book, which is really kind of breaking it down for kind of layman audience, for interested people, I would hope. There's quite a number of YouTube presentations where I'm at least trying to break it down to a certain kind of level that might be more understandable. And we will also publish a new book actually later this year in Germany, and hopefully next year in the English spoken world, which will be a bit of a continuation of that saga that we went on today, and kind of exploring more the kind of nature of what makes us human and how we settled the rest of the world.
Johannes Krause, on behalf of Homo Sapiens, many of whom are listeners to this show, Dankeschön, author of A Short History of Humanity, How Migration Made Us Human, Johannes Krause, thank you very much.
Thanks, Aidan.
Nice one, man. Thank you so much.
Sure, absolutely.